Hi all, welcome to Greenboard. Today we are discussing chapter 1 SIPs of plus 1 NCERT Mathematics. Chapter 1 SIPs. In these days of conflict between ancient and modern studies, there must surely be something to be said for a study which did not begin with Pythagoras and will not end with Einstein, but is the oldest and youngest, G.H. Hardy. So, the mathematician G.H. Hardy says that in these days of conflict between ancient and modern studies, it means there always exists a development from ancient studies to a modern study. What we are doing in mathematics is from the underlying theories and concepts, we are always developing new technologies and applications. So the mathematician G.H. Hardy is saying that in between building these developments from the underlying theories, there exists a conflict, there exists a difficulty. So he continues, there must surely be something to be said for a study. There must exist something to study in such a way that which did not begin with Pythagoras and did not end with Einstein. So something should be exist to study in such a way that it does not start from Pythagoras and does not end with Einstein. It means that it should be easy to study. Okay, by saying that did not begin with Pythagoras and will not end with Einstein, the author is saying that maths is a bit difficult to study. Mostly every students, not only students but also people, mostly every people is approaching maths in a bit difficult manner. Also some chapters of maths are a bit difficult too. So the author is saying that there must be something easy to study for the students. Okay, but it should be at the oldest and youngest. It should have a strong base in the ancient mathematics, but also it should also hold a strong developmental area in the new world. Okay, so our chapter set 1 starts with the quote of G.H. Hardy. This quote is exactly apt for this chapter because the chapter 1 sets is a very easy chapter which we did not have to revise multiple times for facing a public exam. Okay, it's a very easy chapter. Only one equation is coming. It comes on in the last section and it is a very easy equation too. Okay, no need of studying it. By doing two or three problems with that equation, we will automatically study that equation. Okay, it's an easy equation and balance everything. The rest of this chapter has exercises that are so easy. Okay, only need of a simple logical thinking and we can write the answer. No need of multiple revision or memorizing a lots of things. That is not needed for this chapter. So for a starters, okay, this is a complete relaxed chapter. Okay, this chapter gives us an entire relaxation, but it is a very important chapter. That means from here onwards we are stepping into set. So from chapter 1 of plus 1 onwards, the final chapter of plus 2, we will see set. From here onwards, for every chapter there will be a set definition for all concepts. Okay, so it is, although it is easy, it will become a member of our maths from here onwards. Okay, George Cantor, father of infinity. So George Cantor is known as one of the fathers of infinity. There are three fathers for us. Okay, one is George Cantor and John Williams, as well as Srinivasa Ramanujan. Srinivasa Ramanujan is an Indian mathematician. He is known as the man who knew infinity. Okay, he had contributed many inevitable things to maths, as well as John Williams had found the symbol for infinity. And our mathematician George Cantor discovered that the infinity exists not only in numbers but also in many concepts of mathematics. For example, in set theory as well as in trigonometry, sequences, etc., there exists infinity. So George Cantor expanded the view of infinity. Okay, he told us that the infinity exists not only in numbers but also in many concepts. Okay, many branches of mathematics. In left hand side you can see some set theories, set theory notations. Okay, these are the common symbols which we use in set theory. Okay, in the set chapter is underlined on set theory. Okay, for every concepts of mathematics there exists a strong theory basics. Okay, so the set the chapter set has a set theory, and we uses the notations union, intersection, elements, etc. in this chapter. Okay, we usually use to add, that means to add 1 and 2 we use the plus sign, isn't it? Here to add two sets, okay, to add or to combine two sets, we use the simple union. It is represented as u. Similarly, intersection represents the common elements existing in two sets. Okay, similarly there are some notations, elements, subset, etc. We will see it more detail in further videos. Okay, here I am only just giving a brief introduction to the intention of this video is that to just evoke a discovering mind. Okay, a discovering mind in you, a curiosity to just evoke a curiosity about what the chapter contains. That much is the intention of this video. We will discuss the theory sections, or we will discuss the textbook in further video onwards. So let us look what a set is. A set is a well-defined collection of objects. It is a collection of objects, but when somebody asks us what this collection means, we can say what all things exist in it. Okay, when we have a collection of books, and somebody asks us what are they, we can say that it is my book collection. Okay, so the set of all collection or set of all my book collection is a set. Or when there is a fruit basket and it contains many fruits and somebody asks us what are they, we can say it is a fruit basket. Okay, or it is a group of fruits. Okay, then what it means, the fruit baskets represent set of all fruits in the basket. Okay, similarly when we can when somebody asks us what is this, we can give them a answer. That answer means well defined. Okay, so it is a collection of objects, but it represents something. That means well defined collection of objects. Okay, usually we give names like a b c, capital letters a b c etc. for sets. Okay, when we draw a triangle we name it usually, right? Like triangle abc, triangle pqr etc. So in sets also we name them, but in set we name them only a single letter is enough. Okay, so capital letters we use for them a b c etc. Okay, and each and every member, okay, each and every thing or object included in that group of set are known as objects as well as elements or members. Mostly we use element or but we also use the words objects as well as members, but commonly use word is elements. In textbook we can see the three terms using. Okay, but the most commonly used one will be element, but some questions will ask us as objects as well as members. Okay, and in the right hand side you can see examples like natural numbers, integers, rational numbers etc. Okay, so we told that we should represent a set by capital letters. So these are standard notations. We denote natural numbers by capital letter n. The natural numbers consist of the numbers which we see from standard 1 onwards. That means 1 2 3 4 5 6 etc. We cannot write the entire set, isn't it? Because when we write up to 100 there exists 100 and 102 and so on. When we write up to 1000 there exists more from there. That means 1000 and 1002, 10,000, 4,000, 6,000 etc. So we cannot write the entire set, so it is an infinite set. Okay, so here comes the word infinity. Okay, so it is an infinite set, so we will write some elements of it, and the rest we denote by some full stop. Okay, we denote a 3 dot and it represents that the set never ends with it continues. Okay, we write a set in curly brackets. It start with curly bracket and end with curly bracket, and the members of them are denoted in between by separating them by a comma. Okay, similarly the integers represent set of all elements. Okay, positive elements, negative numbers and 0. So all the natural numbers come in integer group as well, but the integer group contains more numbers than the natural numbers. The same group of natural numbers and the same group of natural numbers with negative sign as well as 0. Negative numbers 0 and positive numbers, they constitute the integer set. Okay, and for the rational numbers there comes decimal or fractional numbers. That means any number that can be represented as fraction, that comes in the rational numbers. Otherwise we can tell it in another way, the all the numbers that can be represented as decimals. Okay, for example, 1. Okay, 1, how can we represent? 1 can be represented as fraction. How? 1 by 1, it means it is a fraction. 1 by 1 means 1, so 1 is a rational number. Okay, similarly 1.0, then it becomes a decimal number, isn't it? Then 1.0 is a decimal number, as well as it is a fraction, so that also comes in the rational number group. Also there exists another category, it is irrational numbers. It means root 2, root 3, root 5, etc. The whole collection of natural numbers, integers, rationals and irrationals constitute the real numbers. Okay, real numbers consist of the entire type of numbers which we know till now. That means in further chapter there comes complex numbers. The complex numbers does not exist a real numbers. Okay, the numbers which you know till now, that is the whole universe of real numbers. Okay, so the real numbers is a big group, and balance all are subgroups of real numbers. There are some terms for this big group as well as subgroups. Okay, we will see it in further slides. Okay, so a set has no order as well as no repetition. Coming to the left hand side, the fourth point is a set has no order as well as repetition. What does it mean? For example, consider a set 1 2 3 4. Okay, it can also be written as 4 3 2 1, 4 2 1 3, 3 1 2 4, etc. and so on. There are numerous ways to write a collection of 4 elements, isn't it? So all that ways of writing these 4 elements, that is the collection 1 2 3 4, in how many ways that all can be written, that all are correct answers. Okay, there is no specific order for writing the elements of a set. If somebody writes it as 1 2 3 4 and somebody write it as 3 4 2 1, both are correct and both will get full marks. Okay, also there exists no repetition, there need no repetition. Okay, it also makes the chapter sets more easy for us. Okay, it means 1 1 2 2 3 3 4 4. Okay, then we need to write, there comes 1 in that set, isn't it? 1 comes 2 times, but we need to write only 1 time. Here we are only specifying what all objects are coming in a set. Okay, we don't need to write the number of them. So the if there exists 2 ones, there is no need of writing it as set 1 1. It only need to write 1 1 1 2 2 3 3 4 4. It is wrong, only need to represent the elements. So there is only need to write it as 1 2 3 4. So it represents 1 exist in that group, 2 exist in that group, similarly 3 and 4 exist in that group. We don't need to specify how much 1 exists in that group or how many 3s exist in that group. That is not needed for us, just specify the elements of that group. Okay, so no order as well as no repetition. It makes the set chapter more easy because there need not to count the elements. Okay, so if somebody count and it becomes wrong, in other chapters our mark will lose, but in the chapter said there need not of losing the marks. Okay, we will get the full marks because only need to specify how much elements or how all the elements coming in that group. No need of number as well as no need of representation. Okay, sorry, repetition. A set can be represented in two forms, set builder form as well as roster form. Okay, any set that can be written can represent in set builder form as well as roster form. When we go to the chapter in text exercises, there are numerous questions, like they will give us in set builder form and we have to write it in roster form. Similarly, they will give us in roster form and we have to write it in set builder form. So any set can be represented in two ways. They are roster form as well as set builder form. Since it is well defined, any set has two forms. Okay. For example, a set builder form means a sentence. Okay. In set builder form, we write it in a sentence. That represents that whole group. Okay. And in roster form, we said that it represents a whole group, right? And in roster form, we specify or we write name by name each and every member of the group. For example, set of all colors in rainbow, it represents set builder form because the sentence set of all colors in rainbow has more to tell us, or it has a more specific answer for that. So the sentence set of all colors in rainbow represents set builder form. And when we specifically write the names, that means violet, comma, indigo, blue, green, yellow, orange, red, when we write those names specifically, separating them by comma, then it becomes its roster form. So simply telling, set builder form is in a question mode. Okay, but there does not exist a question mark, but it will be a question mode. And the roster form will be in an answer mode. It has a specific answer and nothing other than that. Okay, so set of all colors in rainbow, it means a question, isn't it? What are the colors of a rainbow? That question is we written in a sentence form, set of all colors of rainbow, then it is a set builder form. And that has 7 answers, isn't it? The 7 colors of rainbows. So when we write those answers or those 7 colors comma by comma, then it becomes its roster form. Okay, we will see it in further examples too. There is an easy example to understand that. Okay, so here we can see a term universal set. The entire group or the biggest group which we are considering is the universal set. Okay, here the biggest group which we are considering is a set of all collection of elements in nature, isn't it? The whole picture or the 8 pictures represented in this slide represents what? The elements of nature, all are found in nature, isn't it? So how can we write it in set builder form? Collection of elements in nature, isn't it? It all are elements of nature. So in set builder form we can write it as collection of elements in nature. And how can we write it in roster form? We have to write in roster form, we have to write each and every element's name by comma after comma. Okay, that means sunflower, lovebird, sparrow, it is a variety of sparrow species. Okay, then grape, orange, lotus, apple, and parrot. Usually we see green parrot, but it is an orange one. I think it is a macaque category. Okay, so that we not need to study. Okay, we just need to specify it in anyway. Okay, so we need to write it as parrot. Okay, so sunflower, lovebird, sparrow, grape, orange, lotus, apple, parrot, then it becomes its roster form. Okay, but in this set we can classify it in more organized way, isn't it? And there exists 2 flowers. Okay, so there can come set of all flowers, as well as there exist 3 birds, then set of all birds, and there are 3 fruits. Okay, then set of all fruits. In such a way this whole group can be classified further, isn't it? It makes this set more organized, isn't it? The way of classifying a set into subgroups is called subset. Okay, the categories coming under a universal set is the subsets. Okay, so there are 2 flowers, then in set builder form the left hand side represents the set builder form and this right hand side represents roster form. Okay, so in set builder form we can write flowers. Okay, then in roster form we have to specify it as sunflower comma lotus. Similarly for fruits, when we write only fruits or the set of all fruits, it becomes set builder form. And when we write it as apple, orange, and grape, it will become its roster form. And similarly for birds, when we write birds, it will become its set builder form, and we specify their name, that means parrot, lovebird, and sparrow, then it becomes its roster form. Okay, then we have already said that there exists no order. Look at this picture once again. Okay, here what comes first? In bird category, what comes first? Lovebird, sparrow, then parrot. But in subgroups, what I have written? Parrot, lovebird, and sparrow. Both are correct, isn't it? When we write lovebird first or second, there happens no difference for the lovebird, isn't it? So there exists no order. In any way we can write, but or we have to specify everything, not the number. Okay, so in flowers, consider those, imagine that there exists a flower vase that consists of only sunflower and lotus. Okay, that flower vase contains a lot of flowers which includes only sunflower as well as lotus. So there should exist more than one sunflower as well as lotus, right? So imagine that there exists a flower vase with a 4 sunflowers and 3 lotus. Okay, so there are whole 7 flowers. And somebody came, a boy came, and we asked us, what do you see? He will say a flower vase. Then we are asking him further, okay, what all flowers you see? Some maybe he will tell sunflower and lotus, but sometimes he will tell lotus as well as sunflower, isn't it? So both sunflower lotus as well as lotus sunflower, both are correct answers. Okay, as well as there exists only sunflower as well as lotus, it is a set of flowers, isn't it? So that group contains sunflower as well as lotus. If it exists sunflowers, sorry, we said 4. If there exists 4 sunflowers, we don't need to tell sunflower, 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 isn't it? It is logically incorrect. So if there exists sunflower, we have to write sunflower, and if there exists lotus, there is only need to write lotus. So repetition does not need us. That means if sunflower, write sunflower. If there are 4 sunflower, also write sunflower. No need of writing sunflower 4 times. Similarly, consider that in your kitchen there exists a fruit basket and it contains many fruits, which includes many fruits means a number of fruits that consist only the 3 types. That means apple, orange, and grape. A fruit basket containing apple, orange, and grape. So there exists 3 fruits in many numbers, isn't it? 3 categories, 3 species of fruits, sorry, 3 variety of fruits in many numbers, but we need to write only apple, orange, and grape. That fruit basket contains apples, oranges, as well as grape. We don't need to write apple, apple, apple if there have 3 apples in that fruit basket. Okay, also if maybe we if our favorite fruit is apple, we will tell apple, orange, grape. Maybe somebody's favorite fruit is orange, they will tell orange, apple, grape. But both are correct, isn't it? So we don't need to specify their order as well as repetition. Okay, think just logically. Okay, both are correct, isn't it? So no order as well as no repetition, it makes our sets more easy. Okay, set theory is easy to study. Imagine that in a tree or in a zoo there exists a big cage of birds, and there are lot of birds. Okay, parrot, lovebirds, as well as sparrow. Okay, and there exists a branch in that tree, and they are sitting here and there with their voices. Okay, chirping voices also exist there. Then when we go to the zoo, we will say, oh, there are lot of birds, isn't it? There exists, what we will say there exists parrot, lovebird, as well as sparrow in that cage. We does not say that there exists parrot, 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 lovebird, sparrow, sparrow, isn't it? It is logically incorrect. Okay, somebody will say there exists lovebird, sparrow, and parrot. Somebody will say there exists sparrow, lovebird, and parrot. 3 types of naming are correct. Okay, so we need to specify only only their species. Okay, there no need to write their number as well as no need to write their order in set theory. Okay, sometimes we can say there exists 4 parrots, 3 lovebirds, and 2 sparrows, isn't it? That is correct, but in set theory only need to specify those varieties. Okay, we don't need to count them. Okay, just specify them. Okay, in this video my intention is to just introduce you to these sets. Okay, in further videos only we will go to the text exercises, so just look at this. Okay, in this slide we are seeing some daily life examples of sets. From by seeing this I think you have understood that what a set means. Okay, there exist two rooms, okay, a neat room as well as a messy room. So in messy room we can see a wardrobe full of clothes, okay, but the wardrobe is shuffled, or it is contained with a heap of clothes, isn't it? But when somebody asks us what is this, we can say only it is a collection of clothes. But in the second picture it is more organized, and we can say it more specifically or more correctly how these the wardrobe has shoes, belts, clothes, blankets, caps, etc. Isn't it? So in the first picture, it represents a whole universe. Okay, the wardrobe represents a universe, and in the second set also, the wardrobe represents a universe. But comparing to the first picture, the in the second picture we can classify it into subsets. Okay, so how can we classify it into subsets? We can see some clothes hanging on the hanger road, so that becomes set of all clothes on the hanger road. Okay, then we can see many folded clothes under, so beneath the hanging road. Then what we can say, set of all folded clothes. Under that there exists a set of a row of shoes or a row of chappals. Then how can we say that, set of all chappals or set of all shoes. Then on the top there exists a shelf, and there exists some, I think it will be blanket, caps, etc. Then what we can say, a set of all blankets, set of all caps. Okay, and on the door there exists a rod, and it contains belt, umbrella and tie. How can we name it in roster form? In roster form we can tell it as set of all daily wearing, daily using items, or set of all um, office items, isn't it? In or set of all things on the door road, it is more correct, I think. But in set, sorry, in roster form, how can we tell it? Belt, comma, tie, comma, umbrella, it becomes the roster form. And in set builder form, set of all objects on the door road. Okay, similarly in the first picture there are many toys scattered here and there, and in the second one that toy box is kept neatly near the cradle. So that toy box represents set of all toys. When we say set of all toys, it becomes a builder form. And when we name each and every toy one by one, there exists a crane, I think, crane, car, bus, ball, jeep, etc. and so on. When we name every toys in the toy box in a one by one, it becomes a roster form. When we say set of all toys, then it becomes roster form. Also we can see many books scattered here and there. So I think the books are disappeared in the second one, so I think it is kept neatly inside this shelf. So how can we name this shelf? In set builder form, set of all books. Okay, and how can we tell it in roster form? Name each book one by one. Okay, so it represents a universal set as well as subset. Similarly in the right side we can see a neat as well as a messy kitchen sink. Okay, in the first one, usually it is the situation in our house too. After just a meal preparation, our kitchen looks like this. Okay, then after cleaning everything, our kitchen too look like so tidy, isn't it? So clean and tidy. So in the first picture we can see many plates and spoons, etc. in that kitchen sink, and in the second one they are all cleaned and is organized in both sides as a rack of plates, isn't it? So how can we group them? Set of all crockery items, I think they are plates that are easy to broke, I think. Seeing them, I think so. So how can we tell set of all crockery plates or crockery items? Then here set of all daily using plates, and also there exist two vessels, I think they are used for cooking. Then set of all vessels, as well as we can see many cups, isn't it? So set of all cups and dishwasher, hand washer, scrubber, a towel. So how can we group? Set of all cleaning items. Okay, then in a cup there exist some spoons and forks. Then how can we classify them? Set of all spoons, isn't it? And also there exist many cups on this side, and here and there. Okay, then combining all the cubs, how can we classify them? Set of all cubs. So a single object can be classified into different subsets. Okay, it represents the way how we are classifying them. Okay, so the set of all, when we classify them as subsets, it represents set of all crockery mugs, set of all crockery plates, set of all daily using mugs, set of all daily using plates, set of all vessels, set of all mugs, set of all cleaning items. Or how can we classify? All the plates can be classified into a single group, set of all plates. All the mugs can be classified into a single subset, how? Set of all mugs. And all the vessels can be classified into a single one, how? Set of all vessels. Okay, similarly a single object, the way we are classifying defines how much objects exist in each subset. Okay, so that's all for today, and we'll see you in the next video. In from next video onwards, we will discuss the theory sections. Okay, we will see the chapter more deeply. There also exists a Venn diagram in this chapter. That all things have a lot of applications. Now I am not telling any applications because you guys are not familiar with the words as well as the usage of this chapter. So in this video I just give you, my intention was just to evoke a curiosity in you, and after taking all the entire chapter, I will prepare a video which represents the applications or the further usage for your further studies or in your future life by using the set. Okay, so that's all for today. See you again. Thank you.